Right. So now imagine we have a model that is trained. We are happy with the performance. We want to save it. So let's first see how we are going to save and how we are going to load the model. So the recommended way is to say use torch.save. Things will change, the file names will change, extensions will change. Sometimes people are now using different ones where it's like safe tensors. Some people we used to use back in the day, not back in the day, it's not really a long time ago, but we used to use pico files and all of that, or bin files. So the extension could be anything. Here we're using PTH, which is just for PyTorch, which is our PyTorch model here. So we are torch.save just saves the model. But then, and once you have it saved like this, what you can do is now we are instantiating a new GPT model, right? It's a new GPT model. This one has not been trained whatsoever. At least the one that we saved here, we trained we trained it a bit with that with the verdict text. So there's a bit of training in there. Now that we've saved it, how do we then load it into this new model? So what you can do is to say device dot, we are going to use CUDA if we have it, or we are going to use the CPU. So in that, we'll say now model, we're going to say load state dictionary. And then we're going to load the model that we saved. And we are going to map the location to be our device. Um, and what we are loading only are just the weights that we stored. And then we change the model into eval because maybe we just want to evaluate it. We do not want to train it or anything. We want it to be in evaluation, in the evaluation. So which means the dropout that was there in this GPT model, dropouts and all of that, they are not taken, they are now disabled because now we are in eval. So someone can send you a model that they would have trained, and then you just load it and you load it in the evals in an evaluation mode, and you start making your predictions. But it is common that we use other optimizers like Adam W, and you saw Adam W, and you would want to save some of the information because it uses history of how it has changed learning rates, how it has optimized the model before. Actually, when you're using Adam W, Adam by itself, and you're learning deep learning, many of the courses for deep learning they use Adam, and you actually print out the history of Adam optimizing the weights. So you want to also save sometimes the optimizer itself and the history of what it has done. So you want to save the state of the optimizer. This is helpful. Let's say you have trained your model for 10 hours today, and you say, I want to sleep. Let me save my model and my optimizer so that tomorrow when I come back, I'm going to pick up from where I left. But I want to make sure that even if my system shuts down, my computer shuts down, I do not lose the progress that I would have made. So you save the model, you save them like this in a dictionary like this. So the model state is just the model state, and then the optimizer state as well. And you store the model like that. This is what is called checkpointing. So you would have checkpointed when you go and you are trying to download models, you might be told about the checkpoint. This model is this checkpoint. The checkpoint was created after 3 weeks of training and all of that. They will explain what the checkpoint is like. So now in our checkpoint, we have the model state dictionary, the optimizer state dictionary, and the model .pth that we have. So now when you have your model, you can load the model state dictionary from the checkpoint. And then the optimizer, you can now load the optimizer to you create your Adam, and then you have your parameters, and you load the state dictionary into those. So it means it's not starting from scratch with maybe this learning rate because that's the default. It would take the learning rate that is now there, that is that is at that optimization that is done before you saved it, so that at least you do not start from scratch as you are now loading this model that was saved. That's it. So now you can then continue your training from where you left off. From where you left off, then you continue, and then after 3 weeks, you say, okay, I'm creating another checkpoint. You create another checkpoint. It's very common for models to have many checkpoints. Then you can pick and choose if you want, because sometimes when you're training these models, sometimes they'll go the wrong way. So checkpointing is very, very important because you might end up going the wrong direction and you revert back to a checkpoint where it was performing well, and you adjust maybe some of your parameters and you eventually find your path. That's why it's so experimental when you're doing data science and training with these models. So that's just it. It was important for us to discuss this because, as you can see now, we are loading the weights from OpenAI. So let's see in the next video how we are going to load the weights from OpenAI.